Today we are going to discuss signal system unit number 3. State space modeling. We are going to use differential equation and transfer function for analyzing the state space modeling. What is a state space representation? It is a mathematical model of a physical system which has a set of input, output and state variables which are related to each other by differential equations. State space modeling because they are easier for the computers to perform matrix algebra, and it can handle MIMO systems, and the state space provides all the information about the system. The state of a dynamic system is the smallest set of variables which completely determines the behavior of the system for any time t. And the state variable of a dynamic system are the variables which determines the state of the dynamic system. A vector whose elements are the state variables is called a state vector. And state space refers to the space whose axes are the state variables. In state space analysis, we are concerned with three types of variables that are involved in the modeling of dynamic systems. R, number of input variables, U of t, M, number of output variables, Y of t, and N, number of state variables, X of t. For R, number of inputs, and M, number of outputs, and N state variables, we can have two state equations as shown. The state space model in time domain can be drawn as follows, where the number of inputs and number of outputs and state variables are given, and we have a set of equations and size of each matrix is given by these notations.